In this video, we're going to talk about how we can get the shape or look of a function using solely its derivative and second derivative. So in this first video, or in this first slide, I just wanted to kind of get some shapes down. Here we say that a shape has a positive derivative. Okay, f prime is greater than 0. Well, that means that the function is increasing. Okay. Next, we say that the second derivative is greater than 0. Well, that means that the function is concave up. So I need a function that is increasing, so positive slopes, and concave up. That would look something like that. Next, I've got a derivative that is negative, less than 0, meaning the function is decreasing. And I've got a second derivative that's greater than 0, meaning it's concave up. Okay, I don't have much room, so concave up. So I need something that is decreasing, but concave up, so something like that. Next, a function, a derivative that's negative, so the function is decreasing. And the second derivative is negative, meaning it's concave down. So I need something that's decreasing and concave down. So maybe something like this. Finally, I have a function, a derivative that's positive. So positive derivative means increasing. And a negative second derivative, so concave down. So increasing and concave down would look something like that. So those are our big shapes here, you know, and those are the things we can get from the first and second derivative. We can know if it's increasing or decreasing, and then we can know if it's concave up or concave down. So how can we use that to actually put together a function graph? Well, let me show you. I'm going to start by just analyzing the first derivative, okay? And in each spot, I'm going to write down what, or in each interval, what I know, okay? So the first slot, the derivative is negative, so the function is decreasing. I'm going to put D for decreasing. In the next interval, from -2 to 0, the derivative is negative, so the function is still decreasing. Well, in the next interval, from 0 to 3, the function is, or the derivative is positive, so the function is increasing. And finally, from -3 to infinity, the derivative is negative, so the function is decreasing. Well, let me fill in some other information here, since at 0, the derivative changed from negative to positive, meaning the function changed from decreasing to increasing. I know that this is a minimum, so I need to have a minimum at 0. And at 3, the derivative changed from positive to negative, so the function changed from increasing to decreasing, so I know that at 3, I need to have a maximum. Okay. Now let me do the second derivative. Okay. From -infinity to -2, the second derivative is positive, so I know I'm concave up. From -2 to -1, I'm concave down because the second derivative is negative. From -1 to 2, the second derivative is positive, so again I'm concave up. And from 2 on, the second derivative is negative, so I'm concave down. So now I basically just go along and make sure to draw these shapes. So to begin with, I should be decreasing and concave up. We know what that shape looks like. Decreasing and concave up looks like this. Okay. Then I continue to decrease, but now for a little bit, from -2 to 1, I'm going to be concave down. Still decreasing, so it's going to look something like that. Okay. Then I continue to, or I'm concave up again at -1. I'm still decreasing, but I got to be concave up. Okay, so it's got to go back to this. And you'll see I'm going to have a minimum at 0. Now where that minimum is, you can, it's kind of arbitrary. You can just kind of put it down and then just kind of draw to it, but I need to make sure I'm still drawing concave up, okay, and hitting that minimum. I'm still concave up. I'm concave up all the way to 2, but I'm increasing past that. So let me draw to 2, something that's increasing, still concave up. Okay. At 2, I change to be concave down, and I am going to reach a maximum at 3. So I could kind of be concave down, reach that max, and come back down like that. Now at this point, it's sometimes good to just go back and make sure you've got it. Am I decreasing from -3 to, or from -infinity to -2? Yes, I am. Am I decreasing from -2 to 0? Yes, I am. Am I increasing from 0 to 3? Yes, I am. Am I decreasing from 3 on? Yes. Then check the concavity. Am I concave up? Yes. Am I concave down? Yes. Am I concave up this whole way? Yes. And am I concave down from 2 on? Yes. Let's do that same thing one more time in this video, or on this slide. I'm just going to fill out real quickly. We know the function is increasing, then decreasing, then then increasing, then decreasing, then increasing. So I know that this is a maximum, this is a minimum, maximum, minimum. Okay. Go down here, this is concave up, concave up, concave down, concave up. The one thing that's different on this is you can see I've said that the derivative and second derivative are undefined. So let's start drawing and see why that occurs. We've got something that's increasing in concave up. That's going to look like this. And then it's decreasing in concave up. Well, it's going to look something like this. So you can see there's a cusp there. Now you also could have accomplished the same thing with a vertical asymptote, but I've chosen to make it a cusp. But something that's increasing in concave up, then decreasing, but still concave up, we run into something like this. And that's decreasing all the way to -1. So again, let's just kind of put in an arbitrary point to hit its minimum. So we'll connect. Still concave up all the way to 0.5. Now it's going to be concave down. We're going to reach a maximum at 2. So concave down, reach a max at 2. Stay concave down to 3. Change concavity and hit a minimum at 4. Something like that. I did that one pretty quickly, but let's just verify it. Am I increasing here? Yes. Am I decreasing to -1? Yes. Am I increasing from -1 to 2? Yes. Am I decreasing from 2 to 4? Yes. And am I increasing after that? Yes. Am I concave up until -4? Yes. Am I concave up from -4 to 0.5? Yes. Am I concave down from 0.5 to 3? Yes. And am I concave up after that?